Welcome to part one of my video on scientific notation. So, standard form or standard notation is the way we are used to seeing and writing numbers. So today we're going to learn about scientific notation, which is a way that we can use to write very large numbers. So for example, we have 12 million here, and we have 0.0008701 are both in standard notation. And I know I didn't read this using place value, but the number was very large. So scientific notation is a shorter way to write very large or very small numbers. So both of these down here are examples to write these two numbers in scientific notation. So we have 1 and 2/10 times 10 to the 7th, and 8 and 701 thousandths times 10 to the negative 4th. Okay, so now we're going to go over rules to convert from standard notation to scientific notation. So the first word here is convert. So to convert from standard notation to scientific notation, we first chop the number where the zeros begin to repeat. Then we place a decimal point such that the number is greater than or equal to 1 and less than 10. We multiply the number by 10, and we count the number of spots you moved and make that your exponent. If your original number was greater than or equal to 1, your exponent is positive. If your original number was less than 1, your exponent is negative. Now, the reason these steps work is because of our knowledge of powers of 10. So when we're multiplying by something like 10 squared, okay, we're really multiplying by 100. And when we multiply by 10 to the negative second, we're really multiplying by 100th. So that's why we're moving the number of spaces based on the exponent. Okay, so we are going to follow our steps and see if we can try these together. So the first step was to chop the zeros where they begin to repeat, and they're beginning to repeat here at the end. I know I see a 0 here, but it's where they repeat at the end. So now what we're going to do is we're going to place a decimal point such that this number here is greater than or equal to 1. So we would put it here between the first and the second number. And we're going to multiply by 10. And we're going to count the number of spots we moved, and we're going to make that our exponent. So we're going to start where we put the decimal, and we're going to count the number of spots we moved till we get to the end of the number. So 1, 2, 3, 4, 5. Now what direction did I go? Good, to the right, so I'm going to make it positive 5. And that's all there is to it. So let's try another one. We have 17 million, so this time I actually have to write it out because the number isn't written for me. We're going to chop it where the zeros start repeating, so I'm going to chop it right here. I'm going to put the decimal point in so that it's greater than or equal to 1, but less than 10, so I'm going to put it right here. And we're going to go up here and write 1 7/10 times 10. And now I'm going to look for the exponent. So I'm going to start where I put the decimal, and we're going to go 1, 2, 3, 4, 5, 6, 7. Which direction did I go? To the right, so it's going to be positive 7. Now let's look at example number 3. Now this is a little bit different. Now the zeros are repeating in the beginning, so I'm going to chop it here. I'm going to put my decimal point in, and if I put it there, it makes it greater than or equal to 1, but less than 10. So this number right here is the root number, and when I want to make it greater than or equal to 1, but less than 10, I always put it between the first and the second number. Now go to where you put the decimal point, and we're going to go till we get to the decimal. 1, 2, 3. And what direction did we go? To the left, so we're going to write times 10 to the negative third. Now some of you are probably wondering, like when I did these two, I didn't stop at the decimal, but really, when you have a number like this, a whole number, the decimal is really at the end of the number. So that's why I'm stopping at the end of the number, because that's where the decimal would have been. Okay, number 4, 207 thousandths. So we write that as 0, 207 thousandths. Okay, now chop it where the zeros start to repeat, and this time they're in the beginning, so I'm going to chop it right here. I'm going to stick my decimal in between the first and the second number, so right here. We're going to write 2 7/100 times 10, and I'm going to start where I put the decimal and go to where the other decimal is. So right here, 1 to the left, so it's 10 to the negative first. Now, I'm not sure if you're ready on your own yet, so you can keep working these out with me here. So here, there are no zeros in the beginning or the end. So here, no need to chop it. So I'm going to stick my decimal between the first and the second number. So 4.0723, or 4 723 10,000ths times 10. Now this time, the decimal is not at the end of the number, it's kind of in the middle, so I'm going to stop when I get there. 1, 2. So this is times 10 to the second. Now this one, there are no zeros repeating. So I can chop it here if I want to. Okay, this is the end of the number, and I'm going to put my decimal in. So I'm going to write 5 46/100 times 10, and I'm going to go till I get to the end of the number. So 1, 2. I went to the right, so it's positive 2. Now look at example C. Now the zeros are in the beginning, so I'm going to chop it here. Stick my decimal in. So I'm going to write 2 37/100 times 10. Now go back to where you put the decimal and go until you get to the other decimal. 1, 2, 3. Which direction did I go? Left, so it's times 10 to the negative third. We have 25,000, so I'm going to write out 25,000. Chop it where the zeros start repeating, so right here. Put in the decimal, so 2 5/10 times 10. And now I'm going to go till I get to the end of the number. 1, 2, 3, 4. So 4 to the right times 10 to the fourth. And this last one here is 6/10, so this is how I write 6/10. The zeros are in the beginning, so I'm going to chop it right here. So I'm going to write down 6 whole. Now really it's 6 decimal, but I don't need to put the decimal if it's a whole number. So 6 whole times 10. And I'm going to start here because this is where the decimal would be in 6 whole if I put it in. And I go 1 to the left, so it's times 10 to the negative first. So that concludes part 1 of our notes on converting standard form to scientific notation. Hope you have a great day.